of this tangent line is rise over run. So the slope is f prime of x. We already established that. But it's also rise over run. So I put the run dx. The question I have is, what can this be? And look at this relationship, because we used it many times before. There are two different notations for the same thing. What could that equal to? The top of that fraction. What could this be? So that f prime of x equals this over dx. What was the second notation we used for f prime? That's where it's coming from. It was this over this, or f prime. What is it?
dy.
Exactly, there is nothing else but dy. So here is dy. Okay, now I need to explain what dx is and what dy is. And you can say, we know. Yes, but they have special names now. Dx is the differential. So we have a lot of words here, right? Big vocabulary. Differentiable, differential, derivative. So this is the differential of x. It happens to be exactly equal to the exact change, but this is, we call it the approximate, although it's not. It's the same with delta x. The approximate x using the derivative. That's why the differential in front. And what is dy? Of course, the differential of y. Which is the approximate delta y, the approximate change in y value using the derivative, of course. Okay, what's the big deal? Okay, nice notations, nice explanation, nice words. What is this all about? It's exactly what we just did with the linearization. The linearization was saying that the line can approximate the function near values, certain value. Same thing here. Because Q is very, very close to P, if I determine the exact change, which is delta y, with f of x plus dx minus f of x, it's going to be very, very close to dy, which is the differential of y. So delta y is approximately dy, because the points are very close to each other. If they're not close to each other, then I cannot use the approximate symbol. So again, what is delta y? Is f of x plus dx minus f of x, as you told me a few minutes ago. Approximately. But now we have to determine this. See, in the past, I did not tell you that dx and dy have specific meanings as well. I always said, is the same notation, do this or this. Yes, but they also have significance. Okay, so I'll copy that here. F prime of x equals dy over dx. Can anyone solve this equation for dy? And I'll put it here. dy equals. What should I do to both sides to get dy? And I'll get it and put it here. What should I do to both sides to get dy? How will you solve this equation for dy? Anyone, please? Anyone, please?
Multiply
Both sides by?
dx.
That's it. So f prime of x times dx. This is extremely important for chapter 4, which is not on this upcoming test. It will be on the next test. So I'm going to copy it here. And what I'm going to do is move this to the other side. And you can still ask, what's the big deal? I'm getting to the big deal in this moment. Why do we do all this? So f of x plus dx, when I move this to the other side, I change its sign, is approximately f of x plus f prime of x dx. Very important. And I'll show you examples and you'll understand what's going on. And I'll tell you it's exactly the same thing. This is the linearization. So the function x plus a little error is approximately f of x plus f prime of the minor error times the minor error. So it's basically all the same. Okay, but what do we do with this? So first, let's choose a few examples to play with this new concept, and then we'll look at word problems. Okay, so first I would like us to choose from 1 through 12. So let's read the question. Find delta y. Okay. Part B, find dy. Okay. Part C, dy for the given x and dx values. Fine. So they want the exact change for a minor error in x. They want the approximate change for a minor error in x. And also they want us to evaluate the approximation for the given values of x and dx. Exactly what we just looked at. So let's choose. Please choose an examples to work on to find delta y, dy, and evaluate dy for the given values. So please choose a problem. If not, I will choose. 1, 2, 2.5, 3. I will choose 5. F of x equals 1 over x, x equals 1, delta x, which is always the x, the same thing, 0.2. I hope I copied everything from one problem, because sometimes I copy from 2. Good. So first of all, they're asking us to find delta y. Well, delta y is f of x plus dx minus f of x. Since we use delta y, it doesn't matter, but I would like to be consistent and use delta x as well. It's the same thing. They are the same value. Okay, so this is our x, and this is delta x. What is x plus delta x? How much? X plus delta x.
1.2.
Of course, 1.2. And f of x, so this is 1. So all I have to do is determine f of 1.2 minus f of 1. And this will be the exact change or error in the function when there is a tiny error of 0.2 when x is 1. Okay, so I'm going to go to the graphing calculator. I will put the function in y equals, and I have 1 over x. Oh no. I have 1 over x. And then I go to second table, and I will plug in 1.2. I will plug in 1, and then subtract them. So the first one is, gee whiz, 8.33. and the other one is -1. So better to do this, 1.2 to power -1 and -1. That was better. So -0.1666, roughly. Or I put the bar on top, and that's exact. So this is the exact change. So that's part A. In part B, they want us to find dy, which is the approximate change with f prime of x dx. I have dx, is very clear, it's 0.2, but I have to find f prime and then plug in 1 in it. Can anyone give us f prime for this function? F prime for 1 over x. We've differentiated this many times before. I know everyone can differentiate 1 over x. There's no need to use the formula. We have a specific formula, I mean the power rule. We have a specific quick formula for this one.
Is it x to the -1/2?
But remember, it's -1 over x squared. There is no need to remember or use the, power rule on this. This is carved in stone, and it's a very important formula. So 1 over x prime is -1 over x squared. Good. So when I plug in, so this is -1 over x squared. So then dy will be, can anyone plug in 1 in here? Because we're asked to plug in 1. So this will be -1 times 0.2. So -0.2. So this is the approximate error, which has to be very close to the exact error. -0.16666666 is not far from -0.2. So dy is a good approximation of the exact. Now in part C, there is a part C there. Where is it? In part C. Find the dy we already did. So this was part C. So in part B, all I have to do is just write this and plug in -1 over x squared. So dy by definition for this function is -1 over x squared dx. I wanted to write it separately as well. So now, can anyone give us a function? Any function. I want to make sure that we understand the difference between the derivative of this function and the differential of this function that you are going to give us. Who would like to make up a function? Please, any function you want. So we fully understand the difference between the derivative of the function and the differential of the function. Who would like to make up a function, please? Anyone, please? Can anyone make up a function? Anyone? Can anyone give us a function? F of x. Anyone? I refuse to believe that no one can come up with a function, any function. Something you saw today or any other function. Anyone, please? Is anyone with me? First of all. No one is with me?
We do 3x of this.
Say it again. 3.
Yeah, 3x of this.
You said 3?
Yeah,
Okay, 3e to the x plus 2x cubed. Can anyone determine the derivative for this function? Three e to the x plus 2x cubed. Can anyone find the derivative for this function, please?
is it 1 over 3x?
When we differentiate e to the x, we get e to the x. That's the nicest function always. E to the x prime is e to the x. So the first piece is 3e to the x. Can anyone differentiate the second part?
6x to the 2.
6x squared. Good. Now the differential is not f prime, but is dy. And as you see it here, is the function times dx. Please understand the difference. See the difference here? The derivative is just differentiating, it's obtained by differentiating the function. 3e to the x prime is 3e to the x, and 2x to the third prime is 6x squared. But whenever we're asked to find the differential, I have to copy the function, put it in parentheses, mandatory in parentheses, unless it's just one product, and then multiply by dx. So that's extremely important, very important to understand. Okay, any questions for me?
Is that a 2x?
I'm sorry?
Is that a 2x? Outside of the parentheses for,
Here,
yeah,
it's dx.
oh, dx.
So the formula is dy equals f prime of x times dx. Now if the function has t in it, then this will be dt. If the function has w in it, then this will be dw. So it's whatever the function has in it.
So is that just kind of a placeholder, or what is it?
This one,
Yeah.
the formula for the differential of y is f prime of x multiplied by dx. And we obtain this from here. F prime of x equals dy over dx. We multiply or cross multiply. We multiply both sides by dx. So this is times dx. If there is no symbol, it's a product. Is that okay?
Kinda.
It's just a product. So we multiply both sides by dx, and we got f prime of x dx. So that's dy equals f prime of x times dx. It's not a placeholder, is a quantity. dx is a quantity.
Oh, so it does have, okay, because
It has a
does
meaning.
have a value behind it.
Yes, it has a, no, it represents, is a number itself, or not. In this case, it's not a number, it's the definition, dy equals f prime of x dx.